Hey, this is Lab 3 for Electrotechnology. In today's lab we will be looking at some new components which are LEDs, LDRs and capacitors. So I'm sure by now you're familiar with the power supply, digital multimeter and breadboard, so we're just going to get straight into actually building the circuit. So as we were shown before, these lines on the breadboard are connected horizontally, so we're just going to use these for our voltages. So for our top set of horizontal lines, we're going to hook in our positive voltage, and for the bottom rail we're going to hook in our ground. This just means that all these points along here are now plus 5 volts, and these lines here are ground. So just before we start to build the circuit, we'll just check that we have our power supply set to 5 volts, so that when we turn it on later on we won't be blowing any components. So we can start to build the circuit. The first circuit is simply a 330 ohm resistor in series with a green LED, and the LED in this first circuit is in what's called forward bias, which means that it is conducting. So the important thing with LEDs is that it's necessary to connect the positive leg of the LED on the positive facing side of the circuit and the negative leg of the LED on the negative facing side of the circuit. This will mean that it's in forward bias, and how you know this with the LEDs is that the longer of the two legs is the positive leg. So now we can set up our circuit. So we can put in our 330 ohm resistor, here, and now with the positive leg, we can put the positive leg into the same rail as the resistor, and then put our negative leg in another rail. So we can hook up our power. So we hook up plus 5 volts to the left hand side of the resistor as shown in the circuit. So we're just hooking it up to the top rail here, and we can hook our ground into this right hand or the negative leg of the LED. So that's the circuit set up. So now we can turn on our power supply of 5 volts, and we can see that now the LED has turned on. Okay, so now for part 2 you're asked to measure the voltage drops across the resistor and the green LED. So surely you know how to measure voltage by now, but for any that don't, we have the red lead plugged into the voltage and resistance port, and the black lead plugged into the common port, and we select voltage DC. So now firstly, to measure the voltage drop across the 330 ohm resistor, we simply hook up the 2 crocodile clips on either side of the resistor, and now we can see on the digital multimeter that this is dropping 2.9 volts. Now for the second part of this, you're asked to measure the voltage drop across the LED. Which you can measure by hooking up the crocodile clips on either side of the LED, and we can see that this is 2.035 volts. So again, as with Kirchhoff's voltage law, we can see that the sum of the voltage drops is equal to the supply voltage in the circuit. Okay, so now part 3 asks us to measure the current flowing in the circuit. So to do this, as always, we change our red lead down here to milliamps, and we change the setting to IDC to measure direct current. So as always with current, we have to break part of the circuit. So we'll just break the circuit here just before the resistor. We can see that the LED has gone off now that the circuit is broken. So now we want to remake the circuit using the digital multimeter. So we can hook in our positive, just the positive leg, and we'll hook in the negative lead onto the resistor. So now this circuit has been recreated. We can see that the LED is turned on again, so the circuit is actually connected, and now we're measuring 9.05 milliamps. So for part 4, you simply repeat this again, but while changing the voltage in steps from 1 volt up through 5 volts. Okay, so now we're going to look at the effect of a capacitor in the circuit. So we're going to set up the circuit as shown in figure 3. So I'm just going to hook in my voltage rails now, and for handiness sake, which you'll see later on, we're just going to put both our positive and ground here on the top 2 rails here. So we got our positive into the top rail and our ground into the bottom of those 2 rails. So now we can start to set up our circuit. So the first part of that is the 33 ohm resistor, which is this one, which we'll just place into the circuit. So now in series with that is a 470 microfarad capacitor, which is this one here. Again, it is important, as with LEDs, it is important that the capacitor be inserted correctly. So the positive leg is the longer one, the negative leg is the shorter one, so you just have to make sure that the positive leg is facing the positive side of the circuit, which is the side that the positive voltage supply is coming from. So we can connect the positive leg in here in series with the resistor that we already inserted, the negative leg into another rail. Now we're connecting 2 LEDs in parallel with each other, but they're in opposite bias. So the red LED is in forward bias, and the green LED is in reverse bias. So we will hook these in now. So for the red LED, we want to hook the positive side of it in to facing the positive supply. So again, the positive side is the longer leg. So we'll hook this into the same leg as the capacitor, and then into one of these rails over here. Now we want to put the green LED in facing the opposite direction, so we'll actually put the negative side of the green LED into the same leg as the capacitor, and the positive into the same leg, into the same rail as you used for the other side of the red LED. If you can see this here. So now we can connect up our power, and just while we're actually hooking in our power, we'll just turn off the power supply. So as you can see in the circuit here, this common rail here with the 2 LEDs is connected to ground. So we'll just hook this up to our ground rail, and now point C is here on the left hand side of the first resistor. So now we'll be using this for the next part. Okay, so now question 2 in section B asks us to connect point C to point A in the circuit. So on the actual circuit itself, point C is here on the left hand side of the 33 ohm resistor, and point A is here where the 5 volt rail is. So we'll turn on our power supply. This wire here is connected to point C. We will now connect it to point A, and we see that the red LED flashes on while the capacitor is charging, and then once the capacitor is charged, it is seen as an open circuit, so current ceases to run in the circuit and the LED turns off. Okay, so now for part 3, we're going to connect point C to point B this time. So when we connect point C to point B, we see that the green LED flashes on. The green LED is in opposite bias to the red, so this turns on when the capacitor is actually discharging, which it discharges to ground through the green LED, and that's why it flashes. The length of the flash was determined by the capacitor and resistor values, which determine tau and the time constant for capacitors charging and discharging.